Hi, my name is Dana Isaacs, and today I'm going to be talking about directional versus non-directional hypotheses. Before you begin to write your hypothesis, you first need to know if your claim is associative or causal. Associative or causal. And the way we differentiate between these is if the predictor variable is measured or manipulated. Basically, if the researcher interferes in some way, it is manipulated, kind of like assigning a condition to a group, or if the researcher is measuring someone in the natural state, that's measured. So caffeine intake, for instance, could be measured or manipulated. So measured would be maybe a self-report on your caffeine intake per week, and manipulated, maybe the researcher is assigning one group to drink 2 cups of coffee per day and another group not to drink any caffeine per day. And then once you decide if your claim is associative or causal, depending on what the researcher is doing, then you can write a directional or non-directional hypothesis. So directional or non-directional. And I will also add the null hypothesis here as well, so we can discuss this. So this is saying that there is no difference between groups. So I'm going to be using A as predictor and B as outcome, just to make this easier. So for null, I'm going to say there is no relationship between predictor and outcome, or A and B. There's no relationship. I'm going to use that for between A and B. And I'm saying relationship because it's association, not causal. So looking at this graph, I'm going to put the predictor on the x-axis and the outcome on the y-axis. So maybe this is level A1, A2, and the outcome on the y. So if we, at the end of our experiment, conclude this hypothesis, there wasn't a significant relationship between groups. Now we're looking at directional and non-directional, which are research hypotheses. For associative claim, I would write there is a relationship between A and B, or you can also say linked with, correlated with, associated. There's actually a whole slide on this in the variables and claims lecture, so I'd encourage you to include that on your note sheets to make sure you have all of these terms. So I can write, for one of them, there is a relationship between A and B. And then I'm going to write, just so you have it over here, linked with works as well, associated, and correlated with. So you can use these terms in directional, non-directional. And so for your directional hypothesis, an example is that I'll do positive and negative. So we're giving it direction. We're saying as one goes up, the other goes up, or as one goes up, the other goes down. So for a positive relationship, you can say there is a positive relationship between A and B. And for a negative association, you can say there is a negative relationship between A and B. So you can write a non-directional or directional hypothesis. Usually the researcher will have something in mind and will give this to you in the prompt. So if they do that, we'd recommend writing directional if the researcher gives it direction. So to think about this in terms of a graph, we are saying that one group is performing better than the other group. This could be a negative relationship. So let's say that group A1 had no caffeine and A2 had caffeine. So remember, and this is measured, we're not assigning groups to have caffeine. So this would be a negative relationship. And then if I were to do, and then I'll put B on the y-axis as well. So if this were the opposite, more of a positive association, group A1 would not have caffeine. So same idea, and the group with caffeine would score better. So B is our outcome. So now I'm going to move to a causal hypothesis. And remember, this is when the researcher is interfering, assigning a certain group a condition. Starting with the null, we're not going to say relationship because we're implying causation now. So relationship implies association. So a way we can do this is saying that A does not affect B. And same idea in terms of the graph, we're thinking of the two groups performing not significantly different. So caffeine would affect both groups essentially the same. And in terms of a non-directional hypothesis, we don't want to give direction. So one way we can write this is saying that A affects B. So we're not implying that A causes an increase in B or A causes a decrease in B. We're just saying that A somehow affects B. So our predictor, our independent variable, somehow affects the outcome. And other ways you can think about this: impacts, influences. There's a whole list on your slide in the variables and claims lecture that you can look at and put on your cheat sheet to make sure you have all these terms. And in terms of directional, the way we can write it is an increase in A causes an increase in B. So that would be for a positive causal relationship. And it'd be, an increase in A. So if you just write A causes an increase in B, that would be incorrect because we're not saying is it an increase in A or a decrease in A causing an increase in B. So for a negative causal relationship, we can say decrease in A causes an increase in B. So if we're looking at this in terms of the graphs, we can say group A1 was given no caffeine and A2, let's say, was given 2 cups of coffee for the week. And here, so caffeine is causing an increase in outcome. And over here, caffeine is causing a decrease in outcome. So the group that wasn't given caffeine performs better on the outcome. So this would be a negative causal relationship, and over here would be a positive causal relationship. So now that we have our framework for writing directional and non-directional hypotheses in the context of associative and causal claims, we're going to practice a few examples. So now we'll do a full example using caffeine intake as our predictor and athletic performance as our outcome. So caffeine intake, again, we can either measure or manipulate it. Maybe the researcher is using self-report for someone's weekly intake of caffeine, and for manipulation, we're assigning a group to drink 2 cups of coffee, and we're assigning a group not to drink any coffee. So for our null hypothesis, let's say the researcher is using self-report to measure caffeine intake. So null hypothesis could be there is no relationship between caffeine intake and performance. I'm just going to shorten athletic performance for performance. And for our non-directional, so now we're getting to the research hypothesis. So we either choose one, directional or non-directional. As long as you label correctly, you can do either one. So for non-directional, there is a relationship between between caffeine intake and performance. So I'm just going to choose the positive association now for directional, assuming that the researcher thinks that caffeine intake is associative with performance. So that would be this scenario here. So I'm going to write there is a positive relationship between caffeine intake and performance. So this is saying the more caffeine, the higher the performance. We're not assuming anything causal. So in another scenario, and you would get this with the prompt, would be manipulated. So let's say the researcher assigns one group not to drink any coffee, assigns a different group to drink 2 cups for the week. That's manipulation. The researcher is interfering, telling you how much to drink. So for a null hypothesis, we can say caffeine intake does not affect performance. And we have to write affect. You'll get deducted points if you do not, since this is a causal claim. And for the non-directional hypothesis, we can say that caffeine intake affects performance. So we're not giving it a direction. Could positively or negatively. And for directional, we're going to again stick with the researcher thinking that caffeine increases performance, but now we're going to write it in a causal format. So you can say an increase in caffeine causes an increase in performance. So we do both of these positive. So now at the end of the study, whether it's associative or causal, we'll analyze the data and we'll figure out if our evidence points in the direction of our research hypothesis or our null hypothesis. So if the caffeine group performed better in either one of these scenarios, then there would be evidence of directional. So we would conclude either this hypothesis or this hypothesis, depending on our scenario. And if the groups did not perform significantly different in terms of caffeine versus no caffeine, then evidence points in the direction of our null. So either this one or this one, depending on if it's an associative or causal scenario.